Hello, my name is Truls Nordby. I'm professor at University of Oslo. In today's webinar about probostats and high temperature measurements, we have something for the nostalgic among you on the history of the probostat. The probostat is a sample holder system for measurement of electrical properties of materials. It specializes in high temperatures and controlled atmospheres. It's by many considered the state-of-the-art cell of this kind, and it enjoys worldwide recognition for this among students and researchers worldwide. But the history of the probostat really starts with my supervisor, Professor Per Kristen Hofstad, who passed away in 1997. His background is from college and university in the United States. He took a PhD there at Berkeley in 1953. He worked at the Central Institute for Industrial Research in Oslo from 1954 to 74. He specialized in high temperature corrosion and started to work with defects and transport in metal oxides. He became a professor at University of Oslo in 1975 at the Department of Chemistry, where he worked with inorganic chemistry. He moved his group to Oslo Science Park in 1990 and changed direction a bit on the research we do in the group towards physical chemistry, solid state electrochemistry, and now the group covers more fields in electrochemistry more broadly. The group was headed from 1997 by me, and now also Professors Reidar Haugsrud and Jonathan M. Polfus are staff in the group. Here we see Hofstad at a young age and at the first electron microscope in the 1970s and at the later age here in Forskningsparken. If we try to understand a bit why we turned to physical chemistry, we can look at the roots of Professor Hofstad. He came from a background in inorganic chemistry and nuclear chemistry and physics, but mainly physical chemistry. His supervisor was Glenn Seaborg, who many of you may know, and his supervisors in turn were George Gibson and Gilbert Lewis, physical chemists that even more of you probably know. So it is easy to understand why we have turned to physical chemistry. There are now 3 students of Hofstad who are professors at University of Oslo. It's Professor Lillerød and myself and Professor Haugsrud. The whole thing about the probostat started with some sample holder cups. In the late 1970s, a later professor from Ural State University, at that time Sverdlovsk, now Ekaterinburg, Alexander Petrov visited Hofstad, and they measured the electrical conductivity of oxides together. And Petrov designed and made the first brass cup sample holder cells. Here's a picture of a relatively early one. It has a loose hole for the support tube up to the sample. Everything is glued and soldered in platinum feed-throughs at the bottom here, quite awkward. And it has copper tubes coming out of it quite simply. When I joined the group around 1980, I started with a master project with Hofstad. I worked on the electrical properties of yttrium oxide. And down in the room ÖK44, ÖK44, I got a cardboard box with Petrov's cups and 4 Brooks show rate 150 millimeter flow meters with red valve buttons to control contents of oxygen in the atmosphere. These 4 flow meters are still in use today in our lab. I had a Keithley 616 electrometer for EMF transport numbers. And we called it the Mazda because Mazda had the model 616 that cost at that time equally much as that electrometer. And we had the Wayne curve manual impedance bridge with 1 frequency, 1592 Hertz. Later on in the 1990s, I started my PhD and postdoc work. I developed the Petro cups further. We got better support for the alumina sample support tubes and enclosing tubes. We got more electrical feed-throughs through it, so we could measure on several samples. But they were still based on platinum wires that were glued through alumina tube stubs. It had better gas connections. Then a clever guy, Ingvar Ring, joined the group in around 1990 and took his master on PhD with us. And he improved the connectors so that we could use coax cables. He made the Swagelok gas connections that were supported on something so that not everything was loose, like in this one. And he later has taken a postdoc at UIO and since 20 years has been a research scientist at Sinter Oslo, still active, very active in proton ceramics for fuel cells and electrolyzers. In 1990, Kofstad's group moved to Oslo Science Park at the edge of the campus. And in the science park, we are supposed to do innovation and commercialization and startups. And after 10 years, we decided to start a company. The idea we had was that it must be possible to make our and everyone else's messy sample holders based on brass and plastic and rubber and not least lots of glue into something more standardized and functional and beautiful. So we worked on that, and we made a prototype for a new cell. We involved the workshop at the University of Oslo, and we were able to make something better. And in 2001, we started the company Norex, Norwegian Electroceramics AS. And the major shareholders are me and others, other Norwegians and even the Chinese. We kept this long name until 2019, where it changed to only Norex AS. Here you see some pictures. Here you see this first prototype that we made in 2000 is still in the use in our lab. Now it's nickel plated and a bit refurbished, but it's still in use. Like all ProboStats, they last very long. And here you see a picture from when we packed the first ProboStat in this box. It was shipped to Exxon Research Labs in the US in 2001. So this prototype requirements for the ProboStat was several. We wanted all tubes and wires to be detachable so that the new ProboStat, everything here is detachable to the hot zone. This means that you can have a clean parts, and you can have good economy because you can make all the parts for the hot zone yourself. We wanted the sample and the electrode contacts to be kept in place by a dynamic spring load, which only has aluminum and platinum parts in the hot zone and the springs in the cold zone. And therefore, it can do measurements up to 1600 degrees. It should have a sturdy sample support tube, which is then fastened here with threads instead of the old hole. We wanted 16 feed-throughs and connections for 3 thermocouples, 4 outer and 2 inner electrode connectors, and 4 shields. So there are many feed-throughs. We wanted 4 quick connects for gas in and out, and we wanted water cooling, and we wanted a stable compatibility that makes the first ProboStats compatible with the ones we make and sell today. And the solutions to all of this was to have the workshop come in and help us to design something new and better. And this solution takes high precision machining, including the drilling of 20 long, thin parallel holes through originally the nickel-plated brass and now through the stainless steel, which is a tough job that only some mechanical workshops can do. And we needed to make a custom development of electrical feed-throughs with gold-plated mini contacts. And we designed the hexagon, this box here, originally handmade of brass plates, and now machined out of one piece of aluminium. Some people ask, where did the name ProboStat come from? Well, it took many restless hours and sleepless nights to come up with this name. I felt that this ProboStat with its enclosing tube had a certain resemblance of a snout beetle. And then I thought, what is the name of the snout? And the name of the snout in Latin is proboscis. Even humans have a proboscis, and the elephant definitely. Proboscis means probe, and that is a good word, but maybe probe sounds a bit unsteady, so I wanted to convince the user that the sample is held steady, and the word for steady is static, and the word for static used in science is stat, like in potential stat and galvanostat. So probo and stat became ProboStat. So we have trademarked this, the ProboStat name. So today, the Norex ProboStat has been sold in more than 400, approaching 500 worldwide, to universities, research institutes, and industry labs. And therefore, students and researchers worldwide are very familiar with it. People know what the ProboStat is, and many know how to use it. The standard version comes with a lot of furnishment for many methods, and the standard version can be furnished indeed for almost all electrical measurement methods. There are some special versions of it today. We have a version with a heated base for water vapor. We have a version for high voltage up to 10 kilovolts, and we have a version for higher currents than the normal few amps. I'm lucky because there are 25 ProboStats in the lab here at UIO, so we have plenty. Many other labs have up to, let's say, three or four ProboStats. And it's referenced in countless research articles on the Norex homepage. You can find this overview, this searchable overview of all research articles that refer to ProboStat. So you can quite easily find a ProboStat article that gives you details on how they used it for something that you may also want to do. That was the little history of ProboStat, and questions and comments and inquiries are welcome to me or to Norex. Thank you for your attention.